Hello and welcome to Calsoft's podcast series. I'm your host. My name is Vaishnavi Kulkarni. I'm multimedia communication specialist at Calsoft. And today we have Kiran with us. And topic for today's podcast is 5G need evolution and its functional architecture. Kiran is Associate Technical Manager in Networking and Cloud Business Unit at Calsoft. He has over 12 years of experience in networking and wireless domain. Previously, he worked with Mojo Networks. Hello, Kiran. It's a pleasure to have you with us.
Thanks, Vaishnavi, for the introduction.
I think without wasting much time, let's quickly jump to the topic. I would like to understand what exactly 5G is.
5G is the next step in the evolution of cellular mobile communication. Countries which want to stay competitive in the global economy, stepping fast towards 5G adaptation. With the explosive growth of connected objects and devices will pave the way to a wide range of new services and associated business models. 5G is envisioned to be supporting the machine-to-human as well as machine-to-machine type of applications. This is going to show its impact in different market verticals. For example, agriculture, energy, e-health, smart homes, buildings, smart cities, autonomous vehicles, industrial manufacturing, immersive entertainment, that is augmented reality or virtual reality, 4K video streaming, etc. All these requirements will certainly impose very diverse functional and key performance indicators. Those should be supported by 5G networks.
Wow, I think this is huge. Tell me, what is the forecast on mobile footprint worldwide in the next 5-6 years?
Sure. With the constantly increasing and highly evolving mobile devices and IoT footprint, 5G is going to be a fundamental enabler of mobile network society. 5G is forecasted to be capturing 15% of mobile network space, including 1.4 billion connections by the end of 2023, while 4G is expected to continue its dominance as a legacy mobile network technology.
This was about the mobile footprint worldwide. Tell me, what does mobile networks impact on global economy and the forecast including 5G in next few years?
In 2018, the mobile industry has contributed more than $500 billion to the global economy in the form of public funding, plus 14 million direct and 17 million indirectly supported job opportunities. Overall, mobile industry is forecasted to contribute about $5 trillion to the global economy, that is 4.8% of GDP in next 5 years. As far as 5G is concerned, it is expected to contribute more than $2 trillion to the global economy within next 15 years and more than $500 billion in the form of tax revenues.
How 5G was started?
Sure. Before discussing about 5G, we should first mention about International Telecommunications Union or ITU, which is a specialized agency of United Nations dealing with radio and satellite communications. It works to improve telecommunication infrastructure in developing world and assists in the development and coordination of worldwide technical standards. This agency has a radio communications wing called ITUR, which issued a set of requirements called International Mobile Telecommunications IMT 2020 standard in 2015 for 5G networks, devices and services. Based on these requirements as a part of IMT 2020, the third generation partnership project or 3GPP, which is a standards organization and a consortium of 7 regional telecom associations and a variety of other organizations, developed the protocol specifications for 5G new radio or 5G NR mobile telephony. 3GPP is primarily responsible for specification development for radio access networks, services and system aspects, and core network terminals.
Kiran, with this, I think I'm keen to know what are the primary usage scenarios as per IMT 2020 standard.
As per IMT 2020 standard, the usage scenarios primarily classified into 3 categories. Number 1, enhanced mobile broadband or EMBB, which focuses on faster connections, higher throughput and more capacity. Examples of these usage scenarios include large data file transfers in the matter of seconds, higher resolution video streaming, augmented reality and virtual reality and etc. Second thing, ultra reliable low latency communications or URLLC. This scenario primarily targets mission critical applications, those require uninterrupted and robust data exchange. Examples for this scenario include autonomous or self-driving vehicles, mission critical e-health applications, etc. Coming to the third scenario, massive machine type communications or MMTC, to connect large number of low power, low cost devices which have high scalability and increased battery life in a wide area. Examples for this include Internet of Things or IoT, smart homes, smart buildings, and smart cities.
This is very interesting. Tell me, what are the timelines for the 5G rollout?
Sure. In December 2017, the non-standalone specifications or NSA specifications for 5G new radio, 5G NR, were approved. Followed in June 2018, the standalone specifications was approved. Deployment of 5G with enhanced mobile broadband support is expected to start from 2020. 5G with URLLC and MMTC support is not expected to be rolled out before 2021.
Okay, so how 5G is different from the previous generation's mobile network technologies?
Okay. Like 3G and 4G, 5G is also a packet switching technology, and it is expected to achieve a peak data rate of 10 gigabits per second. Yeah, as discussed previously, it is envisioned to support various applications with high throughput, low latency, and wide range of network coverage. In order to achieve these key performance indicators, it is designed to make use of the technologies like number 1, millimeter waves to support high-speed broadband communications. 5G makes use of millimeter waves, also known as extremely high frequency waves, whose wavelengths range in between 10 millimeter to 1 millimeter. Second, massive MIMO, which makes use of large number of antenna elements that should be more than 64 in antenna signal processing and to provide spatial multiplexing gain by sending independent data streams on each antenna. Okay. Third, the 5G is backward compatible to support LTE, which is a 3.95 generation technology. 5G is primarily set to make use of virtualization by using network function virtualization and software defined networking. In order to satisfy all its primary usage scenarios, 5G is set to make use of sparse code multiple access, which is a kind of non-orthogonal multiple access. Coming to the operating frequencies, enhanced EMBB applications, which demand extremely high data rates, are set to operate in super data layer, that is above 6 GHz frequencies. All usage scenarios, that is EMBB, URLLC, and MMTC, with wide area and deep indoor coverage, support are expected to be operated in low frequencies, that is below 2 GHz frequencies. All usage scenarios with wide area but no deep coverage support are expected to be operating in C-band, that is 2 to 6 GHz frequencies.
So you mentioned about the key performance indicators. Tell us, what are the key performance indicators as per IMT 2020 standard?
As far as key performance indicators of IMT 2020 are concerned, it majorly defined the performance indicators in case of enhanced mobile broadband and few for ultra reliable low latency communication and massive machine type communications. As per this standard, peak downlink data rate should be 20 gigabits per second, whereas uplink data rate should be 10 gigabits per second. Downlink and uplink data rates in dense urban environments, that is 95% of time, should be 100 Mbps and 50 Mbps respectively. Importantly, latency for packet to traverse in radio network should be 4 milliseconds in case of EMBB and 1 millisecond in case of URLLC. In the same way, control plane latency should not exceed 20 milliseconds in case of URLLC and EMBB. Connection density, that is total number of devices per unit area, should be 1 million devices, which is very huge per square kilometer. This is very specific to support MMTC kind of deployments. Okay. Area traffic capacity should be 10 Mbps per square meter, and peak downlink spectrum efficiency, that is throughput per unit wireless bandwidth, and per network cell should be 10 bit per sector per hertz.
Okay. and how the performance requirements of IMT 2020 are enhanced in comparison with its predecessors, that is IMT Advanced or 4G.
Yes, there is a significant improvement in IMT 2020 in comparison with IMT Advanced or 4G in each of its requirements. As per IMT Advanced or 4G, the peak downlink data rate should be 1 gigabits per second, whereas 5G is set to support 20 gigabits per second. Maximum speed for handoff and cost requirements, that is indicated as mobility here, was set to 350 kilometers per hour for 4G, whereas for 5G the performance requirement is set to 500 kilometers per hour. I would like to share a recent incident relevant to this. In Japan, recently they successfully tested the handoff process of mobile devices in a bullet train, which was traveling at a speed of 400 plus kilometers per hour between base stations. In the same way, as shown in this picture, IMT 2020 or 5G NR is set with multifold performance improvements in comparison with IMT Advanced or 4G. In one way, the new performance requirements in 5G are challenges to achieve as well. Also, as I mentioned earlier, 5G is dependent on NFV and SDN, so in such a way that it offers flexibility in deployment, scaling and maintenance in comparison with IMT Advanced.
Okay. I think with this all, I'm interested to know now about the overall architecture of 5G.
Sure, I am also equally interested. 5G will rely heavily on softwareization and virtualization of the network to enhance flexibility and scalability. End-to-end services along with service orchestrator are present at service level. The service lifecycle management loop will be part of this layer. 5G comes up with the concept of network slicing, which is a composition of adequately configured network functions, network applications and underlying cloud infrastructure, which can be physical, virtual or even emulated resources, RAN resources, etc. are bundled together to meet the requirements of a specific use case. Example, bandwidth, latency, processing and resiliency, etc. All these requirements coupled with a business purpose. In order to make use of the compute resources effectively, the network slices of applications of different domains run on common hardware platforms in multi-tenant mode. Multi-domain network operating system facilitates different adapters and network abstractions above the networks and heterogeneous fabrics. And it is responsible for allocation of virtual network resources, common data acquisition, processing, abstraction and distribution, maintaining network state and network reliability in multi-domain environment. At physical layer, multi-domain applications do share the physical resources in multi-tenant mode by having programmable control at different levels to quickly reconfigure, scale up and down the resources depending on business requirement. The secure network and service management system closely integrated with 5G ecosystem, having trust models covering all players, having avoidance and mitigation procedure for new cyber threats. Also, the management of domain resources and functions, which is part of this function, which takes care of orchestration of RAN, core, transport, NFV, mobile edge computing and infrastructure. 5G network elements follow the recursive structure, that is, they have the ability to build a service out of existing service by scaling recursively or by replacing a part of itself. This is used for easier management of elasticity, scalability and change and helps to handle more complex and larger workloads or service graphs.
Kiran, you mentioned about multi-tenant mode. I would like to understand how multi-tenancy in 5G is different from legacy generations.
In legacy generation network systems, the services do run on the protocol stack which support them, and this stack tightly integrated with the underlying infrastructure, hence forming a monolithic network structure which is inflexible as per different business requirements. In this case, multi-tenancy is not effective. On the other hand, 5G architecture decouples software-based network system and functions from underlying infra resources by utilizing different resource abstraction technologies running on commercially off-the-shelf hardware with integration of NFV and SDN. Hence, they make use of multi-tenancy in an effective manner. So, in this diagram, each and every logical network, along with its application support, will act as a tenant. Coming to the life cycle of a network slice, the management plane creates a group of network resources. It connects with physical, virtual network and service functions. It instantiates all network service functions assigned to the slice, and network slice starts functioning as per the business requirement.
Okay, so tell us in detail about the functional decomposition of 5G architecture.
Sure. The service layer constitutes of OSS PSS systems, business level policy functions, decision function along with application services by the tenant, including the end-to-end orchestration system. Coming to the management and network orchestration layer, the service management function is an intermediary function between service layer and interslice broker, which transforms the consumer-facing service description into resource-facing service descriptions and vice versa. The interslice broker handles cross-slice resource allocation and communicates with service management function. The NFV orchestrator or NFVO helps standardize the functions of virtual networking to increase interoperability of software-defined networking elements or SDN elements. The NFVO performs resource orchestration and network service orchestration as well as other functions. The NFVO is a central component of an NFV-based solution. It brings together different functions to make a single orchestration service that encompasses the whole framework and has well-organized resource use. The SDMO or Software-Defined Mobile Network Orchestrator is the combination of NFVO and interslice broker, which does end-to-end management of network resources. Using the network slice templates, it sets up and merges the slices as a multiplexing point. The VNFM or the Virtualized Infrastructure Manager or VIM and the NFV Orchestrator NFV to help standardize the functions of virtual networking and increase the interoperability of software-defined networking elements. The controller realizes the software-defined networking concepts, extending them to mobile networks, and therefore accommodates two control aspects. Number one, software-defined mobile network coordination function. It is shown as SDMX, which is a cross-slice controller. Example, a RAN controller for the control of cross-slice network functions that are shared by multiple network slices. Coming to the second one, software-defined mobile network control function or SDMC, the intra-slice controller. Example, a controller for intra-slice network function INFs within a dedicated control network slice subnet instance. These controllers expose a northbound interface towards control applications and a southbound interface SOBI towards VNFs and PNFs, that is physical network functions and virtual network functions in the network layer. Interfaces towards the nano layer are provided via the management and orchestration layer interface reference points. Coming to the data layer, the data layer comprising of VNFs and PNFs needed to carry and process the user data traffic. By injecting the executable code into the execution environment of network elements to create a new functionality at runtime, dynamic programmability of the physical and virtual resources can be achieved. Basic approach for this is first by enabling trusted third parties, that is end users, operators, service providers, to inject service in the form of a code to the network. Then behavior of the network resources can be changed or customized through a standardized programming interface. With this, we can see the transition from network of entities to the network of functions. Indeed, this is going to be the network of virtual functions, which will deploy services on demand and on the fly basis.
Wow, Kiran, this was really a detailed explanation of the 5G architecture. Who are the hardware vendors currently working on 5G radio hardware?
There are 9 vendors currently actively working on 5G radio hardware and supplying to various carriers across the globe. They are shown here.
Okay, nice. So I know that Calsoft is already working in SDN and NFV services. Tell us more about it.
Sure. For SDN, Calsoft has expertise in end-to-end engineering of SDN applications, north and southbound plugins for SDN controllers and switches. As far as NFV is concerned, Calsoft has engineering expertise and proven track record spread across various NFV and VNF solutions and different gateway functions for our prestigious vendors.
Wow, Kiran, this was indeed a great session on 5G. I thoroughly enjoyed it, and I'm sure our listeners as well. Kiran, I think I know now how 5G evolved and how it works functionally. I would like to understand more about the wireless networks in the coming future from you. Thank you so much, Kiran, for this amazing podcast.
Thanks, Vaishnavi.
To the listeners, thank you for listening us and stay tuned for more podcasts on 5G and other wireless technologies. Thank you so much.